Today in Capechi's Corner, we're going to work with simplifying rational expressions. A rational number is a number that can be written as a fraction. So we have an example here of 3/8. That's a rational number. When we're talking about rational expressions, we're talking about a fraction whose numerator and denominator are non-zero, so they're not equal to 0. Polynomials. So we have, for our first example is 2x/7. And our second example is 4x plus 1 over 3y. When we want to simplify rational expressions, we need to do a couple things. We want to factor the numerator and denominator completely. We're going to pull those apart. Then we're going to simplify any common factors. The second thing we need to keep in mind when we're simplifying is I have to simplify a monomial for a monomial, a binomial for a binomial, and so on. So what we're saying is, to simplify, the polynomials have to have the same number of terms and they have to be exactly the same, which we'll see in some examples. In our first example, both our numerator and our denominator are monomial, so we need to look at what is similar. So first thing I'm going to do is I'm going to look at my numbers, my coefficient. I have 3/12. And if I were to simplify that, that would give me 1/4. Now we'll look at my variables, and I have x to the second over x to the fifth. I know I need to subtract, so I take 5 minus 2, so I have 3 left on the bottom, and then I have a 1 on the top, so there's my final answer right there. In number 2, my numerator is a monomial, and my denominator is a binomial, so I need to look at this a little differently. I'm just going to rewrite my numerator, because that's my monomial. My denominator is 4x plus 20, so I'm always going to look for my greatest common factor. In this case, it's 4. And when I divide each term by 4, I am left with x plus 5. Now I need to look to see if I can simplify. So my monomials, I have 4x/4. I can definitely simplify my 4's because they are both divisible by 4, so that will leave me an x as my numerator. My denominator is x plus 5. That's a binomial, so I can't touch that unless I have the exact same binomial at the top, which I don't, so that's my final answer right there. Now, a common mistake students make is they think I can simplify these x's, but I can't because the x in my numerator is a monomial, and the x in my denominator is part of a binomial. So remember we talked about earlier saying that you can only simplify a monomial with a monomial and a binomial with the binomial. So this x plus 5 is a unit, so we're not going to be able to simplify it unless I had the exact same thing on the top, which in this case I do not. In number 3, my numerator is 2x to the 5th plus 16x to the 4th. So I want to see if I have a greatest common factor, which I do. I have 2x to the 4th. That leaves me with x plus 8. In my parentheses, that's going to be my binomial. And I'm going to line that up. I have 6x to the 6th. That's a monomial. So I'm actually going to line that up underneath, right underneath my other monomials to see if I can simplify. I'll first look at my coefficient. So I have 2/6. That will simplify to 1/3. And then I have x to the 4th over x to the 6th, which leaves me with x to the 2nd as my denominator. And this x plus 8, again, that's a binomial. That's a unit. I don't have x plus 8 as my denominator, so I know I can't simplify that. So my final answer there is x plus 8 over 3x squared. In number 4, my numerator is a binomial. So I'm going to see if I can factor out a greatest common factor, which I can, is 6. And I'm left with 6 times the quantity of x plus 3. In number 4, I have a binomial. I don't have a greatest common factor, but I do have a perfect square minus a perfect square, difference of 2 squares. That factors to x plus 3 times x minus 3. Now that I'm done pulling apart my numerator and denominator by factoring, I'm going to see if there's anything I can simplify. I do notice that I only have a monomial in my numerator. I don't have a monomial in my denominator, so that 6 is going to have to stay exactly as is. However, I do know I have some binomials that are the same. I have an x plus 3 in the top and an x plus 3 in the bottom, so I can simplify those. So my final answer is 6 over the quantity of x minus 3. And looking at number 5, again, I'm taking my numerator first, and I'll see if I can factor, and then I'll do the same thing to my denominator. So in my numerator, I notice I have a greatest common factor, which is 6, so I have 6 times the quantity of x squared minus 4. all over. At the bottom I have a trinomial, so now I don't have a greatest common factor, but I am going to see if I can factor that. To get to x squared, I have x and x. I have a negative sign here, so my signs are opposite, a positive and a negative. And then I have factors of 2, 2 times 1, that when I subtract, I get to 1. I need my higher factor, my 2, to be a negative, so I'm going to put my 2 here and a 1 here. Now again, when I'm looking, I notice my numerator, I have that x squared minus 4, which is a perfect square minus a perfect square, the difference of two squares. So I have to continue to factor. So that gives me x plus 2 times x minus 2. I have to remember to bring that 6 along as well. I'm going to rewrite my denominator, x plus 1 times x minus 2. And now that I have everything pulled apart, I want to see what I can simplify. I notice I have x minus 2 is exactly the same, so I can simplify those. And that's all I can do. So my final answer is 6 times the quantity of x plus 2 all over x plus 1. In number 6, in my numerator, I do not have a greatest common factor, but I do have a trinomial, so I'm going to see if I can factor that. So I have x and x. My signs are going to be opposite, so I have a plus and a minus. Factors of 10 that when I subtract, I get to 3, which is 5 and 2. 5 is my higher factor, which needs to be attached to that negative sign, so the 5 goes here, and the 2 goes there. And my denominator, there's nothing to pull apart. I just have a binomial, so I'm going to rewrite it x minus 5. Now again, I notice that I have x minus 5 both in my numerator and my denominator, so that's going to simplify. And I'm left with x plus 2 as my numerator. I have 1 in the denominator, so I don't need to write that. So my final answer there is x plus 2. Now in number 7, my numerator is 2x minus 5. I don't have a greatest common factor. In my denominator, I notice that my binomial is not in standard form, so I'm first going to rewrite that. Negative 8x plus 20. So I can factor out of 4, goes into both 8 and 20. However, I usually like my leading coefficient there to be positive, so I'm going to factor out a negative 4 this time. And that leaves me with 2x minus 5. Now, if I'm not sure if I did that right, I can kind of go backwards. Negative 4 times 2x gives me negative 8x. And then negative 4 times negative 5 gives me positive 20. That's what I started with, so I know that I'm okay. So let's rewrite what I have again. So I have 2x minus 5 over negative 4 times the quantity of 2x minus 5. Now, in looking to see what's similar, I notice that I have 2x minus 5 in both my numerator and denominator, so that's going to simplify. I'm left with 1 on the top and then a negative 4. So I can write it like that, or sometimes you see it with a negative sign in front. But regardless, my final answer there is negative 1/4. Now for our final problem for this lesson, we have divide the quantity of 2x squared minus 8x plus 8 by the quantity of x minus 2. So we just need to set this up correctly. So the first polynomial I'm talking about, that's going to be my numerator. So I'm just going to rewrite that 2x squared minus 8x plus 8. I want to divide it by x minus 2, so that becomes my denominator. So now I'm going to continue the problem as I have in the other ones that we did. So I'm going to see if I have a greatest common factor, which I do in my numerator. I have 2, and I have x squared minus 4x plus 4 all over x minus 2. I'm going to see if I can factor that binomial. I have x minus 2 times x minus 2 all over x minus 2. Now at this point we have to be careful. I have a lot of x minus 2's, right? I have 1 there, 1 there, 1 on the bottom. I have 3. I can only simplify 1 for 1. So I have an x minus 2 in my numerator and 1 in my denominator. I don't have another one in my denominator to match with this one, so I have to leave that as is. So my final answer is 2 times the quantity of x minus 2.